Here we have two charges, and we're trying to find the net electric field strength at some given point P, which is between Q1 and Q2. So of course, start off by writing down what we know. So Q1 is 3.2 times 10 to the negative 9 coulombs. Q2 is negative 6.4 times 10 to the negative 9 coulombs. And then there's some distance between the two of them. However, that won't be necessarily super relevant for us. What we're more concerned about is the radius or the distance between Q1 and P, and then the distance between Q2 and P. So we'll just call these R1 and R2. The distance between Q1 and P given in the question is 15 centimeters or 0.15 meters. And the distance to point 2 is going to be 42 minus 15 centimeters. This gives us 0.27 meters. So what we're going to do now, just like some of the other examples we've done, is find the net charge based on Q1, the net charge based on Q2, and then simply add them together to find the total net charge on point P. So what we're going to do here is first solve for the electric field based off of Q1. So that's equal to K Q1 over R1 squared. So that's 9.0 times 10 to the 9 newtons meters squared per coulomb squared times 3.2 times 10 to the negative 9 coulombs, all divided by 0.15 meters, all squared. This gives us a positive value, which makes sense given our situation, of 1.3 times 10 to the 3 newtons per coulomb, and that is to the right. Since Q2 is negative, we're going to probably expect some negative value here. Field at point 2 is equal to K Q2 over R2 squared. Our value for K again is 9.0 times 10 to the 9 newtons meters squared per coulomb squared times negative 6.4 times 10 to the negative 9 coulombs divided by 0.27 meters squared. This is going to give us a value of negative 7.9 times 10 to the 2 newtons per coulomb. So that's a negative value, and that value is towards the left, which means it would give us a positive value towards the right. So positive 7.9 times 10 to the 2 newtons per coulomb to the right. So of course, because our point P is to the left, a negative value then implies that the direction is to the right. This helps us a lot because now both of our directions are positive and they're both to the right, which allows us to find our sum. So the sum of all my electric fields is the first one plus the second one. So we have 1.3 times 10 to the 3 newtons per coulomb, positive value since it's going to the right, plus 7.9 times 10 to the 2 newtons per coulomb, positive value going to the right. And our net is 2.1 times 10 to the 3 newtons per coulomb. And that is also going to the right.